All right, question 3. We have a right triangle here. We're given beta. That's what that B is. It's 49 degrees, and we're given side A, which is 9. And we want to know what is theta. That's another Greek letter we use for an unknown angle. And then what is B and C? So theta, we don't have to use anything fancy for. You just have to know that all three angles in a triangle add to 180, right? So I'm going to take 180 minus our 90-degree angle minus the angle we're given. So 180, minus 90 minus 49. So our remaining angle is 41 degrees. That's theta. And when you type it in, 41 DEG. Okay, now we're solving for our sides, and this is where we have to use sine, cosine, tangent because we only have one side length. We can't do the Pythagorean theorem unless we have two lengths. So pick your reference angle. Doesn't matter which one. I'm going to pick beta just because 49 degrees is already there. And then label your sides. So across from the right angle, that's the hypotenuse. Across from the angle is the opposite. And then the remaining side next to the angle is the adjacent. Okay, and we are going to start with solving for B. So our next step is, are we going to use sine, cosine, or tangent? And I like to ask myself two questions. So my first question is, what do you want to know? And then what are you given? So we want to know the opposite side, and we're given the length of the adjacent. So from here, am I going to use sine, cosine, or tangent? Which one has opposite and adjacent? Tangent. OA, TOA. So then we're going to set it up. We know tangent of an angle, and I don't even need to write the whole thing. We know tangent of some angle equals OA, opposite, over adjacent. So let's plug in what we know. The angle, that's A, is 49 degrees. So tangent of 49 equals the opposite, which is what we're trying to solve for, B, over the adjacent, which is 9. So this is what we call the setup. Now we need to solve. So to solve, I'm going to get rid of this fraction by multiplying both sides by the denominator, which is 9. So 9 times tangent of 49 equals B. And we're just going to put that in our calculator. So 9 times tangent of 49. And notice, that can't be right. We're solving for a side. It's because whenever you open Desmos graphing in your settings, you're in something called radians, which is something that we're learning about later. But it's a way to measure angles. We want degrees. Right now we're talking about degrees. So you always need to go make sure when you're in graphing that you're switched to degrees. And that answer is 10.35. Am I rounding to 2 decimal places? Yep. Okay, now I'm going to find C. And I'm going to go back here and use the same reference angle. And I'm just going to give myself a little more room here. And I'm going to ask myself the same questions. What are you trying to find? What do you want to know? And what are you given? So side C is we want to know the hypotenuse. and we're given the adjacent. So SOHCAHTOA, sine, cosine, tangent, which one has H and A? Cosine. So for my setup, I'm going to start with just the general. Cosine of some angle equals adjacent over hypotenuse. And we're going to plug in everything that we know. So the angle is 49. The adjacent side is what we're given, it's 9. And the hypotenuse is what we're trying to find. So this one has an extra step when we solve, because now when we get rid of the fraction, you always get rid of a fraction by multiplying by the denominator. We have c times cosine of 49 equals 9. But to get c by itself, we divide both sides by cosine of 49. So times, then divide. Side c is 9 divided by cosine of 49. And we're going to put that in our calculator. And I already rounded, or not rounded, I changed to degrees. So 13.72 is our rounded answer.